Alright, calculus, we're about to look into something here called U substitution. This is a very convenient way of doing integration. It helps us kind of shortcut a lot of things, but we just have to make sure that all the pieces fit in the way that we're looking at. And one thing to kind of help us get started on this is it's going to be the chain rule backwards. So let's jump right into it. Let's review a little bit of chain rule. So first, if we were to do something like x minus 3 to the third and take the derivative of that, that would give us, well, the outside is going to be 3 times that piece squared. The inside is x minus 3, and then the derivative of x minus 3 is just 1. Now, if we make this a little more complex, and we're looking at the derivative of 2x minus 3 to the third power, we're still going to have that 3 drop down and the 2 up here. And this time we have the 2x minus 3 inside. But now we're going to have a 2 on the outside because the derivative of 2x minus 3 is 2. Even more so, if we were to take that inside function, let's call it x squared minus 3 cubed, and now we're going to take the derivative. We're still going to drop that 3 and still going to have this 2, and then we have this x squared minus 3 on the inside and the 2x on the outside. So we start to see this pattern in where the inside is an original and the outside is a derivative. So this is going to become our u, and I guess the outside you could call it u prime. Or here's our u and our u prime. And a lot of times now we're actually going to be looking at this as du dx and a whole lot of other details. We can even go so far, doing this with square roots, and we got, let's say, x squared minus 3, the whole thing here, and we take the derivative of that. That's really taking the derivative of x squared minus 3 to the 1/2, which we drop the 1/2, leave the inside alone, subtract 1 from the power, and then take the derivative of the inside. So we're good at this. Chain rule makes sense, but we're really going to be focusing on these layers, this inside and outside layer, and how to deal with that. So let's get started. The first thing to look for is those layers, and in this case we see an inside layer here, and that's going to be our u. In fact, let's color code it. Make it blue. So u equals x squared minus 1. Now, a lot of times people keep going further and try to jump through all the hoops of what to substitute and everything, but I want to see what I actually have to substitute. Because if I substitute what I have so far, that means I have an x, and in here I got something to the 5th power and a dx. And now that x squared minus 1 is just a u, so that's helpful. It's just u to the 5th power here. But I still have this dx and x just sitting there. So what I need to do is take that original substitution that I made, and now I got to take the derivative of that. So if u equals x squared minus 1, now I got to take the derivative of both sides. Du dx equals 2x. And that's what we're going to put right over here. In fact, let's kind of give that a little bit of red. And it says solve for du. Now, from here on out, I'm going to do it slightly differently here. But I want to show you guys what we have and what we're looking for and how to get what we need. So I need x times dx. Those parts are not substituted out, and they need to be, because I can't have u's and x's and dx's all mixed in there. I'm trying to get this translated through a substitution, which means it's got to be in terms of the new variable. Now, u substitution is kind of arbitrary. It doesn't have to be the letter u, but it's what we often use. So I'm looking at this, and I want it to say, okay, back on track here. I want it to say x dx equals something over here. Well, to do that, I could multiply by dx on both sides, and I could divide by 2 on both sides. That would give me 1/2 du equals x dx. Now I have my two pieces, my x times dx, and I can put those together. So in the end, what do we got? When we mix the blue parts and the red, you get purple. Just kidding. All right, so we got 1/2 and du. And that got rid of the x and the dx. And then we got the u to the 5th. Now that we're here, this is so easy to integrate. Because 1/2 u to the 5th du, we just got, the 1/2 is a constant out front, that just tags along. The antiderivative of anything to a power, well, you add 1 to the power, and then you also divide by that number as well. Then we got to add c for our constant. So if I were to simplify this, it'd be 1/12 u to the 6th plus c. But that u actually represents an expression, a bigger inside expression. So this is really 1/12 times x squared minus 1 to the 6th, and then plus c. So the question is that our answer? Yes, it is. We're done. But how do I know that that's for sure true? Let's try to take the derivative and see if we come back and get the same thing that we started with. So the derivative of 1/12 x squared minus 1 to the 6th plus c. Well, that plus c is going to go to 0, so don't need that. The 1/12 is a constant, so that's going to stick there. Then we got a chain rule with the inside and outside layer. We start with the outside, 6 times something to the 5th. And inside we have x squared minus 1, but now we have to multiply by its derivative. The derivative of x squared minus 1 is 2x. So let's simplify things. That means I got 1/12. This 6 and 2 is going to be 12. Then we got an x, and then an x squared minus 1 to the 5th. Well, a 12 simplify. That gives me x times x squared minus 1 to the 5th power. And yes, that's what we have. So let's kind of keep our focus here. As you're going through this, you really have to realize there's only a couple things that we need to work through. The first thing is u equals something. We got to figure that out. And then the second thing is the leftover, which usually has something to do with the du's and the dx's, and we got to figure out what's going on with those and get all that leftover and the constants balanced out. So let's see what we got now. All right, so the inside layer, that's what our u is going to be. So in this case, u equals 3x minus 2. So if I were to do the substitution at this point, I would have u to the 4th times dx. So I got to get rid of that dx now. So let's take the derivative and see what happens. Du dx equals 3. I want it to just be dx. So I got to multiply by dx on both sides. And then divide by 3. So I got 1/3 du equals dx. So in the end, I'll have u to the 4th. I got a 1/3 in here and a du because I got rid of this dx to get the du and the 1/3. So now I can take the antiderivative. The antiderivative, we got the 1/3 as a constant, so that just sits there. U to the 4th is going to become u to the 5th over 5. We got plus c. Now if we simplify this just a little bit, we got 1/15 u to the 5th plus c. Now I left some space there because I actually want to substitute in what u is. And remember that u is 3x minus 2. So that's 3x minus 2. We're going to work our way through some more examples here. We're only doing a few pages. This first part is actually kind of shorter just to get ourselves warmed up. But same process throughout. So first, let's figure out what u equals. It's that inside piece, which in this case is 5x minus 2. So now I'm doing my antiderivative. I'm going to rewrite it. We'll have u to the 1/2. So now I got to figure out how to get rid of this dx. We'll to get rid of that dx, I gotta take the derivative of my original substitution. So we got du dx equals 5. But I want it to just be dx. Now, similar to the last two problems, we're going to wind up having 1/5 du is equal to dx. So that tells me that I can substitute this, and I'd get u to the 1/2. Then we got a 1/5 and a du. So now I can actually take the calculus. I can do the antiderivative. By the way, all that we did was algebra. It's called substitution. That's algebra. Now we're doing calculus. So now it's going to become 1/5, and then we do the power rule with u to the 1/2. That would be u to the 3/2 over 3/2, because 1/2 plus 1 is 3/2, and plus c. Now we got a little bit more simplifying to do here. 3/2 in a denominator is really 2/3. And u to the 3/2 is really 5x minus 2 to the 3/2, because that's what u is. Sound like a poor grammar. U is what u is. Alright, 2 over 15, so we got 2 in a numerator and 15 in a denominator, times 5x minus 2 to the 3/2, and of course, plus the constant. Done dizzle. So we got 2 more sets of pages here to do. Here's the first one, and it's going to follow the same kind of process. First, we start with that inside layer. In this case, it's going to be 6x minus 1. So u equals 6x minus 1. So let's see what we got now. We'll have a 4, and inside here we'll have the u to the 2/3, and then dx. Now this 4, you might be thinking, well, I got to get rid of that. Not really, because when you translate into u, constants are universal. They don't have to be x or u, because there is no x or u attached to it. So in fact, the only thing we need to really get rid of is this dx. So again, let's take the derivative and see what we get. We're going to have du dx is equal to 6, but I want it to just be dx. Whoops. I just want it to be dx. So that's going to be 1/6 du. Okay, 1/6 du equals dx. So now when I'm taking my integral, I'm going to have a 4. I'm going to have a u to the 2/3, and then a 1/6, and then a du. So I took out the dx and made a 1/6 then du. Now I can do some simplifying with the 4 and the 1/6. That actually combines. 4 times 1/6 would be 4/6. I can simplify that to 2/3. So I have 2/3 u to the 2/3 du. Taking the antiderivative of that. So the constant is a constant and just stays there. And then u to the 2/3, I got to add 1 to the power. So that means add 3 over 3. I would get u to the 5/3 over 5/3 plus c, of course. Let's do some simplifying. We got 2/3, then 5/3 in the denominator becomes 3/5. And then u to the 5/3 is really going to be, well, what was u? 6 something in there. 6x minus 1. So we got 6x minus 1 to the 5/3 and plus c. These 3's will reduce or simplify, however you want to say it, and it'd be 2/5. Okay. Now it looks like it's getting more challenging, but in fact it's not. Just keep it simple. Answer, what's u equal, and then look for your leftover. So in this case, u equals x squared minus 2. So let's rewrite and see what we have, and kind of keep that highlighted there. So we're going to have u to the 1/2, but we still have left over an x and a dx. So you got to take the derivative and figure out what that x and that dx would simplify to. We know that du dx would become just 2x. But I want it to just be an x and a dx. So I have to divide both sides by 2, or multiply this other side by 1/2. And then I got the du. So 1/2 du equals x dx. So if I take both of those pieces out, I'm going to replace it with 1/2 du. So putting it all together now, we'll have a u to the 1/2. We got a 1/2 du. That 1/2 can be written in front. So let's go ahead and do that. We'll put 1/2 u to the 1/2 and du. So the constant, it stays. And now we add 1 to the power of 1/2. It's going to become u to the 3/2 over 3/2 and plus c. Now it's just a little bit simplifying, a little bit of algebra again. Well, 1/2, we got to flip this denominator. It'll be 2/3. Then u to the 3/2. But instead of saying u, let's say what u is. In this case, x squared minus 2 to the 3/2 plus c. These 2's would simplify. We have 1/3, but you guys can do that. That's easy stuff. All right, two more. Remember to stop, slow it down, move it to where you need, but we keep on moving here. So let's start out with what u equals, that inside layer. Notice that I know this is going to be my inside layer because it has 2 pieces. Even though the x squared might be something that's a little bit challenging, that has 2 pieces, and that's what I'm really looking for. So u equals 1 minus 4x cubed, which means this is really the integral x squared dx times u to the 1/2. So I got to get rid of this x squared and dx. Well, to do that I need to take the derivative. So we got du dx is going to be equal to negative 12x squared. But I just wanted to say x squared dx. So I got to divide both sides by negative 12 and multiply by dx. So I'll have negative 1 over 12 du equals x squared dx. All right, now I'm ready to substitute these 2 pieces, the x squared dx, for a negative 1/12 and a du. So I take those out, replace them with negative 1/12 and a du, and we got u to the 1/2 in the middle. And hey, what do you know? That's pretty easy to work out. So u to the 1/2 is going to have an antiderivative. Of course, this constant negative 1/12 is just there. U to the 1/2 becomes u to the 3/2. We're going to divide by 3/2. We got plus c. Again, we got a little bit of algebra to do. This will be negative 1 over 12 times 2/3. And then u, in this case, is really 1 minus 4x cubed. And that's raised to the 3/2 power, and plus c. The 2 and the 12 would make a 6 in the denominator, 1 in the numerator, so we'd have negative 1 over 18 times 1 minus 4x cubed to the 3/2, and plus c. Easy peasy. You want to see it again? There it is. It's moving away. Here we go. Alright, so looking at this last piece, I know that there's a lot of stuff going on. Some people like to rewrite this right away. We have x times 2x squared minus 1 to the negative 1/3 power. No matter how you write it, it's still pretty easy to see what the inside layer is. In this case, it's 2x squared minus 1. So u equals 2x squared minus 1. Let's see what we got so far. It's going to be the integral of x times u to the negative 1/3. So we got an x and a dx that we need to take care of. This x and this dx. Which is going to require us to use a derivative. So we got a du dx going to be equal to 4x to the first power. Now again, I want this to be x dx. So how do I get that? I'm going to divide both sides by 4, or multiply by 1/4, you could say. And multiply both sides by dx. That'll get rid of the dx over here. That'll get rid of the 4's over here. And I have x dx equals 1/4 du. Alright, so now that we are that far into it, let's substitute back in, see what we got total. We're going to have the antiderivative of 1/4 du gets rid of this dx and x. So we got 1/4 and a du. And we got u to the negative 1/3 in the middle. The antiderivative is going to be 1/4 is still 1/4. U to the negative 1/3 becomes u to the 2/3, because negative 1/3 plus 1 is 2/3. We also divide by that. And of course add the constant. Simplify. We'd have, well, let's take out the u. This is going to be, what was u? It's 2x squared minus 1 to the 2/3 power plus c. So now this constant out front, this coefficient is going to become 3/8. We got 2x squared minus 1 to the 2/3 power plus c. Done. Awesome. Okay, so that's it for part 1. It's just kind of a warm-up. Part 2 is definitely more the intermediate and advanced level, so we are to be continued.